Thank you for logging in. Today I'm going to share with you the first video from the RSA Academy for the Maths Department. It's actually a maths challenge that I set some time ago. It's something that I actually picked up from Twitter. So the maths problem is this. So what you have is a semicircle, and you're told that the rectangle is 16 centimeters by 6 centimeters, and what you're asked to do is to find the shaded area, and that's in terms of pi. So a calculator is not required here. So if we actually look at this problem in a bit more detail, what we have is the following. We have this distance here, which is 16 centimeters, and we have this distance here, which is 6 centimeters. And if I take the middle, which is about here somewhere, and then if I was to draw a line from the center of the rectangle to the outside, what you'll actually have is that then actually becomes the radius. Okay. So if I do that here, that actually becomes the radius. So that'll leave me with a situation where we actually have this, where we'll actually have, and I'm going to draw this freehand now. So I think it might be better that I use the tool actually. Right. So we'll have the side of the rectangle, and then we'll have this halfway point, and then we'll have the radius of the circle. So we have the right angle here, and we've already been told that this length here is 6, so that's 6 centimeters, and we've been told that this is 16, so half of that is 8 centimeters. So by Pythagoras, you may already have worked out that has to be 10 centimeters, but we'll pretend that we don't know that. So if this is an exam question, it would be good to sort of state Pythagoras that a squared plus b squared equals c squared. We do the substitution, and obviously these are the shorter sides. This is the right angle, that's the hypotenuse, and I'll just call this c for the time being. So basically, if we do the substitution, I always tell students use the lower value first, so that'll be 6 squared plus 8 squared equals the hypotenuse squared. That will be 36, and obviously 8 squared is 64, and that will give us c squared, and that gives us 100, and of course c will be the square root of 100, which is actually 10 centimeters. So we know that our circle has a radius of 10 centimeters. So what we can do now is we can move on to the second part. So I'll just delete everything. Okay. So we know that this distance here is 10 centimeters. This question now comprises of, well, what is the area of the circle? Well, in our case, the semicircle. Well, area is pi r squared, and since we actually only want the semicircle, it's actually pi r squared over 2. So that'll be pi times by the radius, which is 10 squared, divided by 2, which is 100 pi divided by 2, and that simplifies to 50 pi. So that's the area of the semicircle. And obviously what we need to do is we need to take away from that the area of the rectangle. So the area of the rectangle will be so the area of the rectangle be, as we were told, 16 times by 6. And again, since this is a non-calculated question, 16 we can break down into 2 times by 8 times by 6. Well, we know that 8 times 6 is 48, so this is the same as 2 times 48, and that is 96 centimeters squared there, and obviously that's 50 pi centimeters squared. Now we need to find the shaded area, and obviously that's going to be the difference of the two. So very simply, that's going to be the area of the semicircle. So shaded area will be the semicircle, which is 50 pi, take away 96, and of course our answer will be in centimeters squared. And the way that question has actually been answered, you would gain full marks. At every stage you've justified, you've shown the examiner fully how you've gone about this, and again I stress that will be a non-calculated question. I hope you found that useful, and obviously what I'll do is every week I'll set a challenge, and then I'll give you the answer, and at the same time set a new question. So just to confirm with you, my name is Narendra Sander. This is my email. Please, if you've got any questions, drop me an email, and I would love to hear from you on Twitter. So thank you very much. Over and out.